everyone, I'm back again. So today we'll be starting with the fifth chapter, that is elementary shapes 2D and 3D. It's comparatively a long chapter, but again this is again an important chapter where you will be you'll get the knowledge of the basics. That's why the chapter name is that basic elementary shapes and the basic geometrical ideas, where you will be only getting an idea. We will be not going too much into the deep of it because class 6 standard you should know only the basics, because basics is only important, but later on in your class 7, 8, 9, 10 standard, these things will be used as a part of a question. They won't be teaching you what is the point, what is the line, what is the line segment. Nobody is going to teach you again and again. So here what we are going to learn, angles, perpendicular bisectors, right? So in this chapter, whatever we'll be learning it, again, this is an just an idea that you should know about it, what are the terminologies and how the terms are related, and then we can these things will be used later in your life. So let's start with it. Okay. um so here we'll be learning, these are the topics which we'll be learning in this class, right? We'll be learning, just a second. Yeah. So we'll be learning measuring the line segments, angle measurement and classification, perpendicular lines, perpendicular bisectors, and the classifications of the triangle. These are the things that which we are going to learn in this chapter, right? Okay, so we have already learned it. What is a line segment? Line segment is basically the distance between the 2 points, which is in a straight line, not in the curvy position, right? A line segment is a fixed portion of a line, and the length of the line segment can be measured because it has two endpoints, right? So as I said, from A to B, you can go in a straight path. You can go from like this, like this, like this, like this to like this, or you can go like this and like this, like this, like this, like this, like this to B, right? But these are not the lines which I have made with the red colors are not the line segment. It means what? From A to B, you have to go in a straight line, right? You don't have to go like this and that, right? So if you, it means like you say like this, then you went like this, like you will say like, ma'am, you went in a curved position. You can go in a straight position also, like this, then like this, and then like this, and then you coming back to this position. No, still it's no. It means what? From A to B, that you cannot go to the other position. You have to go straight in the straight direction. Like you have to just point it towards the B and go in that direction. You cannot change the direction, right? So this is known as what? Basically the line segment. And we have learned that line segment are been denoted by like this or by BA. You can write AB or BA, doesn't matter, with the just a line on it, just a line on it, right? We have learned. So we'll be learning that how you can measure the line segments on a line. Yeah. So there are the various ways where you can measure the line segment. One, by comparison by observation, right? The first method is what, beta? Comparison by observation. Like here are the two figures you can see as they are approximately, right? So here you can see that AB is greater than CD. But if you see this figure, this in this figure here, you can say what? AB is greater than CD by observation, right? Here you don't need anything like observation, right? But if you see over here in this given figure, AB and CD, can you say that these two are equal? Are you sure these two can be equal? But if you have seen the scale, right? Everyone have seen the rulers, right? I have a ruler in front of me. Can you see this? Right. So in the rulers, you see that from zero, like a ruler start from 0 to, like I have a 0 to 15, and I have a ruler from 0 to 30 right with me, right? So if I say like a ruler is like this, I made a line like this and I made a line like this. So can you see that these two lines are made up of the equal length? No, you cannot be sure by observation. But when I say not sure, right, here you cannot be sure about it, right? But if I made a line like this and I made a line like this, line segment like this, so here you are sure that this is, if I name this as PQ and this name as CD, so here you are sure that yes, PQ is greater than that of CD. So sometimes what happens when you see the line segment, sometimes the observation works, but not always. Yes, observation is not a very appropriate method to measure the line segment because you cannot give the exact value of it, right? So here you cannot be sure that these two line segments are same. It can be same, it cannot be same, it can be approximately same, right? So here we are not talking about anything approximately, we are talking about the accurate line segment measurement, like comparison, right? Second beta comparison is by tracing, right? So let us suppose if what I'm going to do, I made a line segment like here, right? And I made the line segment somewhere here. So I think so everyone have seen the tracing paper, right? Everyone have seen the tracing paper. So on a tracing paper, you will keep a paper like this, right? You will keep a paper on AB and then you will put it on CD. If they matches, then they are what? Equal. And let us suppose if they do not match, then they are not equal, right? So tracing is also not, again, or not a very convenient method. If you see, like if you're going to put a sheet of paper like this on it, right? And then you make a line, and then again you go and put it over here, and then make a line over here on this part. So this is again not a convenient method to do it, because all the time you need a tracing paper, and then you have to do once on AB, then again on the CD to see that both are correct. So not a very good method, right? Not very good method, right? Very good method. So this thing you can read it out, like I'm not going to write so much for this, like so you can just read it on your NCRT. It's written like the paragraph, and it's like a history, geography, or like that. You can just read it out, right? Not a very good method, right? And not a good method, and not very accurate, and not very accurate, not very accurate, right? See what happened, like if you have like we have done like since when we were like in a nursery, remember our teacher used to say, like they used to make a dotted line like this, and they say to just pencil, like you have to just move your pen on A and on the B and on C. So we used to, like, that is known as what, basically we were tracing the like path. So sometimes what happened while tracing it, see, like right now I'm also tracing, my hands are not very accurate, right? So what happens, so tracing always not leads to you in a very accurate measurement, right? Now coming to this third method, that is comparison by using rulers and dividers, right? Rulers and dividers are basically, see, only if you're going to take the rulers, right? So let us suppose you might be saying, ma'am, if I have a line segment, so I'm going to place my ruler over here. This is your ruler, right? This is your ruler, right? Put your ruler on the zero. Yeah, this is your zero over here. You put your zero over here. And then you measure the line segment from the putting the rulers, right? But what happened? This is again only by rulers. If I talk about only by rulers, this is again not very effective. Why? Because what happened? This is your eyes, right? So the best way is to observe it from the 90-degree, right? This is the correct observation. But let us suppose if you have observed in this way, yeah, and if you have observed in this way, right, in this way and in this way, right? So this is a wrong, this one is wrong way, right? This one is again you will get a wrong one, right? But this is right. Right means what? Here you should be making a 90-degree. So this one is what? A right observation, right? Because what happens, sometimes the thickness, maybe the reflections of the light will not give you the accurate answer. Sometimes what happens, it's like 4.1, it can be 4.2, but a point difference. If you see, everyone have seen this game since your childhood, you see that from 0 to 1 there are 10 divisions, right? From 0 to 1 there are 10 divisions, right? So in the 10 divisions, if you're observing in a different direction, this is going to give you a wrong answer. But ruler and divider give you the accurate, like this is like most appropriate, like most accurate answers you get over here, right? So this is the best method, this is the best method, right? Best method. Yeah, this is the best method. What happened, you have, like let us suppose you have a line segment, right? Here you don't have to worry about in which angle you're looking in, right? So what you happen, like in your geometry box you have a divider, right? You have just two needles on it, right? So put a divider on the line segment A and B, right? Now what you do, you put the line segment on the scale and see where it is measuring. So this is the most appropriate method. Now here the divider screws are very tight, it cannot be like just, so you have to be a little bit careful. You don't have to like here and there just press it down or like that. So here, when you will be careful by taking the divider very properly, put the divider on here and here, and then put this directly on the scale, you will see that you will get the accurate answer. Whether you can start from zero or anywhere position, you will directly get the definite answer from this. So this is the most appropriate method which has been used for measuring the line segment, but I have seen students not using it very much, right? So this is the most appropriate method which you should be using, everyone, because while doing the construction, we prefer student to measure the line segment by using the dividers, not by the scales, right? So this is the most appropriate, like you put to, yeah, you put your divider on the zero, right? You put your divider on the zero and then see where it is going, just measure it, that's it. You don't have to see that you're going from this angle or this angle, or you're looking just straight, right? So this is like the best and the most appropriate method, like you get the most accurate, you get most accurate, you get most accurate answer from this, most accurate answer from this, right? Answer from this, right? Now, coming to the next slide. Now, it says that draw a line segment AB, take any point C line between AB and measure the length AB, BC and AC is AB is equals to BC plus CB, right? So let us suppose I made a line segment like this, right? So this is A and this is B. It says that take any point C. So this is a point C I'm taking, right? So if the AB length is what, 10 centimeter, right? And I just place this thing on the 7 centimeter line. So this is 7 centimeters. So this length will be how much beta? 3 centimeter. And this length will be what beta? 7 centimeter or not, right? So can I say that take any point and measure the length? So I measured, I took like AB is equals to what? Let it's like assumption. You can take let. It's let. That's why I'm writing let. You can take 12 centimeter, you take 8 centimeter, you take 9 centimeter. Choice is yours, right? So for my convenience, I took 10 centimeter, right? And then I placed AC is equals to how much beta? 7 centimeter. And CB length is equals to what? 3 centimeter. So can I say that ACB, can I say that ACB are collinear points? Yes or no? These are what beta? Collinear points as well? Collinear points. Yes or no? These are what collinear points because it's lying in a straight line, right? So can I simply say that if you're going to add this thing that AB is equals to what? AC length plus CB length, or you can write like this, that is AB length is equals to what? AC length plus of BC length. Both are same. Line segment can be written as AB or BC. Both are same. Just we written CB just to see that we are in the continuation of it. That's why we write CB. Otherwise, there is no difference of it, right? Okay, coming to the next segment, then we say, okay, I didn't say it's true or not. Yes, it's true. I didn't write that. It's true. Okay, now coming to what you mean by the right angles and the straight angles, right? So we have seen what the angles are, right? Angles क्या होते हैं बेटा? What are the angles? Angles we have seen, like if you take this is like the ray. If you take the ray or two line segment, like if you say this is your initial arm, right? And this is your initial arm, and this one is your terminal arm. Actually, we say this as terminal arm. Terminal arm means what? It is moving. This arm is moving. It is moving, right? It is moving. And this one is fixed, right? This initial arm is what beta? Fixed. So what happen if you're going to just make this fixed and if you're going to rotate it? So this one is what beta? The angle, right? So you see that in a one complete rotation, like we see that, we say that in one complete rotation, right? In one complete rotation of terminal arm, one complete rotation of terminal arm, it is equals to what beta? 360 degree. This is we have assumed, right? So it's like this. Now what happened means your initial arm, if you're going to initial arm, when the initial arm and the terminal are on the same, like this is my initial arm and this one is my terminal arm, and I'm just going to place it over here. So this is big will what beta? 10 degree, like 0 degree, right? So I just move, and this is like terminal arm is moving. So this is going to be what? Let us suppose in a clock, it's 1 o'clock, right? So let us suppose your hour, like minute hand start from 12 and it keeps again on like keep on moving, so that your hour hand goes to what? 2, and your minute hands rotate to what? 1 full round to get a 360 degree or not? Yes or no? Yes? Okay. So basically what happened, one complete rotation of a terminal arms give you what beta? 360 degree, right? Or basically we can say that one turn. We can say this also as one turn, right? Now what happened, we have just given the specification, like we know that this is like east, north, west, south, right? So if you're going from like what happened, you can go in the clockwise direction or in the anti-clockwise direction. Like rotation can be like rotation can be clockwise or anti-clockwise. Choice is yours, right? Anti-clockwise. So what happened? But for class 6, but in class 6, we prefer we prefer what beta? clockwise, right? Just for our convenience, right? For clockwise direction. You can go like this from north to east, or you can go from north to east. If you will go from north to east, right? If you're going from north to east, it will be what beta? Clockwise, right? Clockwise. But if I go from east to north, right? East to north, right? East to north, like directly, right? Directly. Okay. Not going in this way. East to north directly. I write directly. Okay. Otherwise, you can go from east to north like this also in the clockwise direction. East to north, then it means what? It is what? Anti-clockwise direction. Anti-clockwise. Anti-clockwise, right? So we have seen that beta. If you have just taken a one complete turn, so what happened? Like one complete rotation, your complete turn gives you what beta? 360 degree. This is important. Like one complete rotation, or this is equals to how much beta? 360 degree, right? This is important. Now what happened? Like if you have just, what do you mean by straight line? Okay, so if I just write over here, um okay, just a second, let me just change my color. Okay, so if you just rotate one, like see, this is like one. Now again you rotate two, then again you rotate three, and then again you rotate four. So basically means what? You are turning in a four turn, right? So 1/4 turn is equals to how much beta? 90 degrees or not? Yes, if I say 1/2 turn, yeah, revolution is equals to what? Like 1/2, just half of it, like directly from here to here, from north to south. So this is equals to what? 180 degree, right? So basically 90 degree means what? A right angle. That's why it says that right angle, right? And over here it says that what a bit of what? Straight angle. We have learned this. This is straight angle, right? So if you move in a right angle, so if you say from 3, like 12 to 3, you have moved what? Like 90 degree, right? Then 3 to 6, it will be again 90 degree, right? And then 9 to 6 will be what? 6 to 9 will be again 90 degree, and 9 to 12 will be what? Again 90 degree, right? So this is what we have learned. Now one more thing I really want to say over here, like in a clock, right? Let's talk about in a clock, right? In clock, you have one revolution is equals to how much beta? 360 degree, right? Yes. So in a clock, if you have a clock, right? So you have 12, this is 3, this is 6, and this is 9. Here 1, 2, 4, 5, 7, 8, and this is what? 9 and 10. 9, this is 10, and this one is 11, right? Now, if this is your clock course, so beta see, this 360, like 360 revolution has been divided into how many parts? 12 parts. Yes. So if you're going from like 12 to 1, what is the angle that you will be sweeping out, right? In a clock that it's divided what beta? 12 parts. Yes. 360 is divided into how much part beta? Divided into how many parts? Divided into 12 parts. Yes or no? So one part will be how much beta? One part will be equals to how much beta? 360 divided by what? 12, which is equals to what? 30 degree, right? So if you're moving one part of clock, one part of clock is equals to how much beta? Right? It is equals to what? 360, 30 degrees, right or not? So this is the important part. That's one part of a clock is known as what beta? 30 degrees, right? So if you see that the temperature, what fraction of a clock clockwise revolution does the hour hand of a clock turns when it is goes from 3 to 9. So if you're going from 3 to 9, yeah, this is 3, this is 12, this is 6 and 9. So you are going from here to here, right? Here to here. So you're going how many turns? Like 4, and this is 5. So how many gaps? Like 1 part, 2 part, and 3 parts, right? So 1 part is equals to how much beta? 1 part is equals to what? 30 degrees. So 3 part will be equals to how much beta? 90 degrees or not? What is the fraction? Fraction is what? If 90 degree means what? 1/4 of revolution. Yes or no? 1/4 of revolution? Yes or no? Now let's see the B part, right? I'll just do the B part over here, right? Like this. Now it says that 4 to 7, right? 4 to 7, right? So this is 12, this is 3, this is 6, and this is 9, right? So this is 4 to, like this is 5, 4, 7, and 8. Now it says from 4 to 7, right? It's going. So how many parts? Like 1, 2, and 3. Again, 3 parts. So one part is equals to how much beta? 30 degrees, right? 3 part will be equals to how much beta? 90 degrees. Again, 90 degrees. So what fraction beta? This is like 1 by 4 of revolution, right? Yes. Similarly, it says from 7 to 10, right? 7 to 10. So it's like 12. This is 3, this is 6, and this is 9. So this is 7, 8, 9, 10, and 11. So it's going from, if you see this, it's going from 7 to 10, right? 7 to 10. So how many parts? Like one part, two part, and three parts, right? Again, three part. So one part is equals to how much beta? 30 degrees, right? So three part is equals to how much? Is equals to 90 degree, which is equals to like 1 by 4 of revolution. Yes or no? Yes. Okay. Now let's coming to, oh my bad, my bad. It says 3 to 6. Oh my goodness. 7 to 10. It will be 10 to 7, right? If there's something mistake over here, let me just go. It's, I made 3 to 6. Let me just made it clear again. Wait a minute here. I didn't see this, so let me remove this part. It's 3 to 9. It's not 3 to 6. I was just thinking somewhere else. Okay, it's 3 to 9. Okay. Okay, so it's going from 3 to 9, right? So this is 7 and this is 8. So 3 part, 4 part, 5 part, and 6 part. So 6 part you have traveled. So it will be what beta? 6 into 30, which is equals to how much beta? 180 degrees. So 180 degree means what? Half of the revolution? Yes, one half of the revolution, right? Yeah, this will be 1/4. Now coming to the next slide, it says that acute angle, obtuse angle. Actually, what happened? There should be one correction. It goes 90 degree. So the fraction is no. The fraction is what? Better 90 by 360, which is equals to like 1/4. Yeah, this is the correction because this is wrong. It says over here rotate by 90 degrees. So the fraction will be 1 by 4, not 360. Okay, so there are three types of the angles which you should be knowing. What are the types of the angles there are? There are like three types of the angle. One is what? Acute angle, one is the right angle triangle, and the other is what? Beta? Obtuse angle triangle, right? So acute angle triangle means what? Now see, let's see over here very carefully. This is what? Beta? Initial arm, right? Initial arm remains the fix, and this is what? Beta? Fixed, right? And this one is what? Beta? Terminal arm. This one is what? Beta? Terminal arm, right? This one is terminal arm, and this is what? Beta? Moving. This one is moving. So what happened? It's moving. Like let us suppose when the terminal arm and the initial arm are on the both of the angle, so it is what? Beta? 0 degree, right? But it is rotated, the terminal arm rotated so that the angle is like 89 degree, but it cannot be 90 degree, right? So when, what you mean by acute angle? That is an angle between, that is an angle an angle greater than greater than 0 degree less than less than 90 degrees, right? So this is known as what? Beta? Acute angle, like 60 degree, for example, 42 degrees, for 73 degrees, yeah, etc., right? Or I can say like 2 degree, right? What do you mean by a right angle? When the angle is what? Beta? Now this is again an initial ray, yeah, initial arm. Yes or no? This is what? Initial arm, and this is what? Terminal arm, right? So when a terminal arm and the initial arm are exactly at 90 degree, right? So the angle between them is what? Beta? 90 degree, right? So that is known as what? Beta? A right angle triangle. So then when the angle between, when angle between two rays, yeah, two arms, say between two arms, yeah, two arms is 90 degree, like exactly 90 degree, is said to be what? Beta? Is said to be right angle. Is said to be right angle, right? So can I say that all right angles are perpendicular, or I can say yes or no? All right angles are perpendicular, yes or no? Basically, the perpendicular means what? When the two lines intersect each other at 90 degrees. So we did in the last class. So are known as what? Beta right angle. We are just talking about the angles, right? What do you mean when obtuse angle, right? Obtuse angle means what? This is again initial, this one again terminal, right? So this is what initial, and this one is what? Beta terminal, right? This is what terminal. So what happened over here when the angle is like, angle is greater than 90 degree, like you have just keep on rotating. When it's greater than 90, but it cannot be greater than like less than 180 degree, like 179 degree it's maximum, right? So that is known as what? Beta obtuse angle triangle. Obtuse angle triangle are generally like this, like open mouth, like this. Acute is like this, like this. If you see, this is acute, this is right, and this is like obtuse, right? So if you just open a big mouth, let us suppose you're so hungry, right? So you open a big mouth, so it's obtuse. When you're less hungry, you just open your mouth like this, little bit, like this much. And when you're like, okay, yes, I can eat it, like the simple way, yes, I'm hungry, I want to eat it, not forcefully, so you're 90 degrees, like that. You can say, just take a simple example, it's just a joke, right? So basically, when angle is greater than 90 degree but less than 180 degree is called obtuse angle, right? Obtuse angle. Yes. Okay, now let's coming to the types of angle over here. Like see, now it says that when the angle is exactly right. So this one is what? Beta terminal initial, right? I'll write initial as I, and this one is what? Beta terminal. So when they're in a straight line is formed. Like let's suppose I took this, like these are the two rays. So this is what? An acute. This one is what? Right. This one is obtuse. So you keep on rotating, and you just went to the half of the revolution. So this is what? A straight angle, right? So when the angle between the two arms, we say that when angle between two arms are 180 degree, here is 180 degree, right? Is 180 degree is called straight angle, right? Straight angle, right? Now, what happened to the reflex angle? Now, let us suppose we have reached. Now, this is the way we are rotating, right? So, my angle was here. This is acute. Now, this one is right angle. Now, I'm rotating a little bit furthermore. So, this is now obtuse. I rotated, so it became a straight line. Now, I just keep on rotating like this. Now, I'm just coming into the backward direction. So, this one is fixed. So, see this pen is more fixed. Now, I have just moved like this, like this, like this, like this, like this, like this. I can coming to this position or not in this way, right? In the opposite direction. So what happened now? This is like greater than 180 degree, but less than what? Beta 360 degree, right? So basically, when an angle is greater than 180 degrees, but less than 360 degrees is called reflex angle, right? What do you mean by complete angle? Like let us suppose this one is fixed, right? And I keep on rotating. This one is like what? My terminal arm, right? So the terminal arm and the initial arm, like let us suppose I'm rotating. Now this has become straight. Now again rotating, and I came back to the same position, right? So what happened? I just turned one revolution, and the zero, and like if I say 0 and 360 are the same, yes, the positions remain the same, but what happened? In terminal ray have rotated at least once. That is known as what? Beta 360 degree. So it means what? When the angle between the initial, when the angle between the arms, when the angle between the arms is 360 degree is called complete angle. right? Okay, I'll give you one example over here. Yeah, let us suppose I made a figure like this. Chalo. So can you see this looks like an acute, 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 right? But I made a figure like this, and like this. So this one is an obtuse, right or not? This is what obtuse. Yeah, this one is acute, and this one is again an acute, right or not? Yes. So similarly, you have to just see the figure how the mouths are opening. So if I make the figure like this also, right? So you see that this angle is what, beta? This is what? A reflex. This is what? Greater than 360? Yes or no? 180? Yes or no? This is what? Greater than 180 degree. It's not less than. It's reflex, right? This one is reflex. But if I talk about this angle, so this will be what? An obtuse? Yes or no? Yes, this is what your acute, this is an acute, this is an acute. So sometimes what happen, you should know which one is like acute and obtuse. Later on, there will be the questions in your higher classes that the angle between them is an obtuse. So better make the triangle in that way, okay? Not like not an acute one, right? So coming to the next, come like angles as right, straight, acute, obtuse, or reflex. So this one is what beta acute. Simply, this one is obtuse. Yeah, this one is what? Right, right. This one is what beta reflex. Yeah, this one is what? A straight angle, right? And this one is again an acute, right? But if I say that this angle, so this one will be what beta reflex, right? Okay, angle measurements. Like, see, you measure the angles. Till now, you have just known that this angle, if it's like it's less than zero, like 0 to 90, acute. Right angle, like when it's 90, then right angle 90 is greater, but less than 180-degree, it is what? It's obtuse angle. When it's 180-degree, it's a straight angle, right? When it's greater than 180, less than 360, it's a reflex angle. It's equal to 360 when the angle is like just completed one revolution. So if you like, this is the protector, right? Protector has been like you have got the protector in each of your geometry box, right? Everyone have the geometry box with you. So you get such type of the figure with you, right? So what happened, like one complete turn in is called a one revolution. It's divided into 360 equal parts, right? So you see that it's divided into 360 equal part, and each part is a degree. So we measure the angle in the terms of the degree, right? And we can measure the angle by using the protector at this level, right? And we will be doing so, right? So we'll be measuring the angle by using the protector. Not at this level, we generally measure the angle by using the protectors only, right? So there are two ways. See, if you see the protector, there are the two types of the line. Here, zero is starting from here, the inner one, and here the zero is starting from the inner one. So let us suppose if I made an angle like this, right? Like this and like this, right? So you're going to place a protector. Let us suppose this is the angle I made, right? Like this. Yeah, this is the angle I made, right? So what you have to do, this is like this point, you have to put it over here, right? And see, this is the way. Now, what happened? You see that this is a zero line. This is what beta zero line. So you will be taking in this direction, the inner one, like inner circle or not? Yes or no? The inner circle, yes. But similarly, let me change my color and then I'll show you. Let us suppose I said to measure that this angle, right? That this angle, yes. So similarly, if I said to measure this angle, so see, you're going to place the point over here. Now this is your zero. This is the way you will be placing over here. Let us suppose you are placing like this, right? So you will be taking what beta? Now zero, this is what? A zero line for the black one. This is a zero line. So you will be what? Taking the outer circle or not? You will be taking the outer circle. Yes or no? Now read it out. So it is what? 0, 10, 20, 30, 40, 50, 60. And this is what beta 70. So this one was what? 70 degrees. And this one is what beta 40 degrees. This is how we measure it. So be careful which one you have to take, the inner circle or the outer circle where the line goes, right? The 0, 1, which side the 0 is going, you have to take that one, right? Now coming to measure the angles given below and using the protector write down the measurements. So you can do this, right? You can do it, right? Yeah, in your book. Okay. Now coming to the what are the perpendicular lines? Perpendicular lines means what? When the two lines intersect each other at 90 degrees, right? When the two lines intersect each other at what beta? 90 degrees, right? Perpendicular lines, we have already done that. When two lines intersect each other at 90 degree, right? So let us suppose that this is what 90 degree, right? So here you see that the angle between the lines are what, 90 degree. So can you see that AB is a straight line also? So you can just say that 290 degrees sum up to what, beta, 180 degrees, and the 490 degree will be what, sum up to what, 360 degrees, yes or no? So let us suppose if I write like this, this is A, this is B, and this one is C, right? This is C and D. So how we denote it? This is how we do. Now it is represented by like this. It is represented as such that AB is perpendicular to CD. This is the symbol. This is the symbol for perpendicular. Symbol for perpendicular, right? Perpendicular, right? So this is a symbol for perpendicular. You are making a 90 degree over here, right? So AB is perpendicular to CD or CD is perpendicular to AB. You can say any of it, right? So if I make a line like this, right? And I make a line like this, and then I make a line like this, right? So I am just naming this as A, this as B, this as C, this as D, and this as B, and this as Q, right? So can I say that AB is perpendicular to PQ? Yes or no? Yes or no? So AB is perpendicular to PQ. Actually, if you're going to extend the PQ line, it's going to be perpendicular to CD also, right? So if you're going to extend this, if you're going to extend this line, so you can say that CD is perpendicular to PQ. We can say like that also, right? Okay. Coming to what are you mean by perpendicular bisectors? Perpendicular bisector means what? You take the line, right? You take the line. Okay. Right now, you see that you have taken a line segment. See, perpendicular bisectors are made on the line segments. Perpendicular bisectors are not made on the lines, right? Here we have taken the line. Here the lines work. Here you can work with the line, and here you can work with the line as well as for the line segment. It works for that. But here what happens for the perpendicular bisector means what? Perpendicular bisector means what? There will be a line or a line segment which divides a line segment into a two equal parts, but intersecting those line will be what? They will be at the angle of what, beta? 90 degrees, right? So I'll write it down. A line is called perpendicular bisector of a line segment if it bisects the line segment and it and is perpendicular to it, right? Now, see over here, you can see that AB is being like what? You see that CD is what? Can I say that AB is perpendicular, like we can say that CD is perpendicular to AB, right or not? And we say that D is what, beta? Midpoint, like half point, midpoint of AB, yes or no? So can I say that AD distance is equals to what, beta? BD distance? Or can I say instead of writing BD distance, I'll write DB distance. It's DB distance. And can I say that this is half of what, beta? AB or not? If AB is what, 10 centimeters, so D will be what, beta? 5 centimeter. This is 5 centimeter. This one is what, 5 centimeter. And this is AD is equals to what, 10 centimeter, right? But what happened here, you can see like that. Here I made a line segment like PQ. right? And I made this as a line. PQ is a line segment, and this one is a what, perpendicular to it. And I wrote this as C and this one as D. So over here we can say that PQ is perpendicular to CD, and here CD is the perpendicular bisector of what, beta, PQ. Here CD is perpendicular bisector because it's bisecting. This is the strokes I make. The strokes are equal. CD is perpendicular bisector of PQ, right? So I'm writing this point as M. So can I say that PM is equals to what, beta, MQ? And can I say this half of PQ or not? Yes or no? Yes? That's it. Right. So whenever it says that CD is a perpendicular bisector of PQ, it means what, CD is bisecting the PQ. Yes or no? Or if I write XY is perpendicular bisector of AB, then what is the figure you will be making? You will be making the figure. XY is the perpendicular bisector. So AB will be what? Definitely a line segment. AB will definitely be the line segment, and PQ can be a line, it can be a line segment. So you can draw like this, right? So this is what XY is a perpendicular Y. This is X, and this one is your Y. So this is equals to this, and this is making a 90 degrees. So I'm naming this as M. So AM is equals to what, beta, MB, right? Now coming to the illustration over here. Which of the following models are the perpendicular lines? The adjacent tops of the top table. Beta, the tables, like if you take a sheet of the paper, any sheet of the paper which you take, right? If you take any sheet of the paper here, this is what, always a T, right or not? So this is always adjacent. Adjacent means what? Bagal bagal ka side. So yes, this one, right? The lines of the railway tracks. If you see the railway tracks, so railway tracks, not the wooden part, no. Railway tracks are always the lohe wala part, yeah, metal parts in which, on which the trains are running. So these are what, beta, parallel. These are what, parallel. So here, no, right? The line segment forming the letter L. So this is yes, L. This is 90 degrees. So yes. The letter V. So it's no. The letter V, no. You can see the figure. These are the railway tracks, right? The top of the table. So this is like 90 degree, 90 degree. This one is 90 degree. This one is 90 degree, right? Coming to the triangles, right, Peter? We have done triangles again in the last chapter only. Okay. So we have done, say, triangle is basically a polygon with the three sides, and the rest of the part we did in the last class, right? Polygon with three sides, right? With three sides. Yeah. Acha, can I say that this is a two-dimensional figure? Yes or no? Because you can draw it this in a sheet of paper, right? And it have three vertices, it have three sides, it have three angle, and the sum of the angle is what, beta? 180 degree, which we did in the last class, right? Okay. Now let's do the classification of the triangles on the basis of the sides, right? So when all the sides are unequal, right? All sides are unequal, right? All sides are unequal, then it is called scalene triangle. Scalene triangle. Let us suppose I made the figure, this is as 8 centimeter. We are talking about the sides. We are not talking about the angles. Angle can be acute, angle can be obtuse, it can be right. But right now we are talking about the sides. We are just looking on the sides, not on the angles. So this is what, 9 centimeter, 7 centimeter, and this is what, beta, 6 centimeter, right? Yes. Now, when I say that any two sides of the triangles are equal, right? We have to see the triangles. Any two sides of triangle, any two, but third has to be like unequal. When any two sides of triangles are equal, then it is called isosceles triangle. Isosceles triangle, right? So can I say this as 7 centimeter, this one is 7 centimeter, and this one has like 6 centimeter, right? So the two has to be equal, the third can be unequal, right? When all the sides are equal, when all sides are equal, when all sides are equal, then it is called equilateral triangle. Right? It is said to be what beta? Equilateral triangle means all sides are what? This is 5 centimeter, this is 5 centimeter, and this one is also what? 5 centimeter. Right? So we have learned like when all the sides are unequal, then we say this as a scalene triangle. When any two sides are equal, then we say this as an isosceles triangle. And when all the three sides are equal, then we say this as an equilateral triangle. Right? Now, classification on the basis of what beta? On the basis of angles, right? You have to see the angles, right? You have to see what beta? All the angles over here, right? So if you see, you don't have to see the sides, you have to just see the angles. Here, all the angles are what beta? Acute. Yes, when all angles are acute, when all angles are acute, then it is called acute angled triangle, right? Acute angled triangle, right? Acute angle triangle, when all the angles are acute, right? Acute angle, right? If you see that any one angle of a triangle is 90 degree, right? Can you have in a triangle 290 degrees? You cannot have, because the angle sum of a triangle is what beta? 180 degrees. If the two angles will itself become 180 degrees, so you cannot have two triangle with two right angles, right? So if like when a triangle have one right angle, one right angle, then it is called right angled triangle, right? Now, if any angle is like obtuse, like any one angle, when a triangle have one obtuse angle, then it is said to be what beta? Obtuse angle triangle, right? So can a triangle have two obtuse angle triangle? Like can a triangle can have two obtuse angle? No. What is an obtuse angle triangle? The angle greater than 90 degree. So if any angle, like let us suppose I am taking 91. So if I take the two angles of a triangle be 91, 91, so it is what? Already greater than 180 degrees. So a triangle cannot be formed. This we have already done in the previous class. So right. So when a triangle have one obtuse angle, then it is called obtuse angled triangle, right? Yeah, this is said to be what? Obtuse angle triangle. Now, here is the figure given. Name the types of the following triangles, right? Triangles with the lengths like C with the sides, all the three sides are different. When all the three sides, see, it's given the side, all the three sides are different, so it is said to be what beta? Scalene triangle, right? Scalene triangle, right? Now, in the triangle ABC, two sides, all the three sides are what beta? Different. A, B, B, C, C3 are different. So again, it is what beta? Scalene triangle. Right? In the triangle PQRS, it says that PQ is equals to QR is equals to 5. And when all the sides are equal, then it is said to be what beta? Equilateral triangle. Equilateral triangle, right? Now, it says that in the triangle DEF, how you're going to make this triangle? You're going to make this triangle like this. So D is what beta? 90 degree. This is E and F. So if one angle is what beta? Now talking about the angle. So we'll say this is as what beta? Right angle triangle. Right angled triangle. Right? Now it says that here, over here, see this is like over here, this is wait a minute, they said ice right isosceles, right? See, this is the nice one, good. This is good one question, right? See over here. In the question number E part, they are saying that in XYZ triangle, Y is 90 degree, right? So this is what? Y is 90 degree, you made Y 90 degree. So this is x and this is z. Now it says that xy is equals to what beta? Yz. Now we have seen that right now we have learned if the two sides are equal, then it is said to be what beta? Isosceles triangle. And when it is a 90-degree, we say this as a right angle triangle. So what we do combine both of them. We combine both of them and we write this is as what? Right isosceles triangle. We combine both of them. We say this as right isosceles triangle. Now look at the F part. It says that this is like it's saying angles. So when it's talking about angle, it's not saying about the side. So we say acute angle triangle. We will not say scalene triangle. We will say what beta? Acute angle triangle. Here all the angles are what beta? Different. So here we say this as what? Acute angled triangle, right? Acute angle triangle, right? So this is like acute angle triangle. So we are done with the first lecture. So in the next lecture we'll be doing some more questions on it, and we'll be doing this is a very big topic. So in the next class we'll be doing more of the 3D figures and the properties. The next lecture is going to be a little bit long. So the next lecture will be doing the properties of like the special type of the quadrilaterals, and we'll be doing the 3D figures, and then we will be doing what beta? We'll be doing the questions, more of the questions on it, and that's that lecture. It's going to be a little bit like a lengthy lecture. Okay, so just keep on practicing, everyone. Any doubt that you have, please post it on your forum, and you can ask with your respective teacher in the class itself any doubts regarding it. So thank you so much. I'll meet you in the next class. Okay, so thank you so much, Vijay.